Okay, so thanks again, and thank you everyone for joining us today to discuss this fascinating topic, whole wheat flour. So I will start with a little bit of context and a little bit of history. This is very interesting to know that, of course, at the ancient times, Roman times, Greeks, etc., all wheat products were whole grain, but even then, there was this need, this desire for the whitest possible bread. And this desire grew up to the late Middle Age, when buying and consuming the whitest bread possible was a sign of wealth. So this was at the time where sifting methods were developed. Then in the late 19th century, the flour has become even whiter, and this is due to the generalization of the use of roller mills. And just like that, the white flour was available for everyone and not just the richest. And it was only in the early 20th century that appeared this challenging idea brought by nutritionists. Does whiter means better bread? And well, it was a very challenged idea at the point that met a lot of resistance. And this is only through a lot of communication and a lot of research that now we are able to say that, yes, whole wheat flour is definitely better for the health. And it is better mainly because of a high content of fiber and a high content of minerals and micronutrients. And that brings a lot of benefits for the health. For instance, it controls obesity, it helps reduce type 2 diabetes. The list goes on and on. And because of that, the market for whole wheat grain, for whole wheat products is expanding, and it is expanding quickly with an annual growth rate of 6.7% per year. This is a lot. That should bring the market value to $132 billion by 2032. So yeah, very interesting market to go into. So let's try and give a definition of whole wheat flour. This is a definition that is under review at various levels. Still, the work is in progress, but it is still, it is now a little bit, well, we are reaching a consensus. And the most interesting part of this definition is that all anatomical components, including the endosperm, the germ, and the bran, must be present in the same relative proportions as in the intact kernel. This is a good first idea, but still there is a lot to define. For instance, there is an incredible diversity of whole wheat flour. Just like white flour, it will depend on the crop, on the type of wheat, on the milling process. Also, the existing rule for claiming whole grain on packaging will change depending on a country or another, or sometimes they are unclear. There are no reference values for whole grain and no existing rules for recombination practices for whole grain. So a lot of work. So that means also a challenge, and this challenge is for the entire industry, starting from the miller. Whole wheat flours, they have a shorter shelf life and also a higher risk of rancidity due to a high amount of lipolytic enzymes. And also, and this is an important shift in the process for miller, sometimes there are no tempering step for whole wheat flour. And for the baker, the product itself is very challenging because it contains a lot of fibers. And fibers that will impact the entire process. They will absorb a lot of water. The kinetic of water absorption is not the same. They will prevent the gluten of forming a network efficiently. So that will impact the extensibility, the elasticity, and of course, the final product characteristics. It will have a strong impact on the organoleptic characteristics, but still, the final consumer needs consistency. If he likes this bread made by this brand, he will like to find the same bread the next time he buys the same brand. If the taste or the shape or whatever changes, he might be disappointed. And this is something that we don't want. So if we try to summarize, there is a lot of variability of the raw material, additional production challenges, and still this consumer need for standardized high quality products. So that means that we have every interest to anticipate what will happen during the process and what will be the quality of the final product. And if we look into the world of quality control when it comes to whole wheat flour, we realize that it's very limited. It's most of the time when you have specifications, most of the time it's granulometry, humidity, and protein content. And the question is that enough? And of course not, no, it's not, because it doesn't give us an idea about how the dough is behaving. So rheological parameters should be included, just like white flour. And it is not the case today, because most methods that we use at the lab have been designed to control white wheat flour. And as we have seen, whole wheat flour is a completely different product. So until now, no method was really suited to the analysis of whole wheat flour. So this is something that we have tried to look into here at Chopin at KPM, and we have developed several methods, and I would like to focus on two. First of all, I would like to speak about the Mixolab. So this is an equipment that measures the evolution of the dough consistency as a function of mixing and temperature. And that allows us to see the water absorption capacity of the flour, and then the behavior of the dough during mixing, so development time, stability. And then the temperature starts to increase. And this gives us an information about how the gluten network handles the temperature, which is related to the volume. At a certain temperature, we reach gelatinization of the starch. And this is related to the crumb structure of the final product. Then the starch gel will weaken, which is due mainly to the amylasic activity. And that gives us an indication about the color. Finally, the temperature goes down, and this allows us to simulate what is going on when you take the bread out of the oven. Basically, we can predict the shelf life of the final product. So we can see that this is a very complete characterization of the flour, and there is a standardized method for white flour. And last year, we have developed a protocol for whole wheat flour. It was done in collaboration with the Wheat Marketing Center. Mainly, the main difference with the standard protocol is a higher mixing speed, which allows us to have a faster dough development. And we have analyzed here 19 whole wheat samples from different countries, and we can see an incredible variability. And this confirms the necessity of control, because this is obvious that this flour will not behave the same way than this flour. We have done the same kind of work with another equipment, which is the Alveograph. So the Alveograph methods measure characteristics of the dough, such as the tenacity, the extensibility, the elasticity. So very interesting parameters of the dough. And this is a very historical equipment. It was on the market 100 years ago already. And it was in 2016 that we have launched the Alveolab that allows to really be more flexible. And before that, it was really not possible to analyze whole wheat flour. And now, thanks to the Alveolab, we can modify the protocol, for instance, by increasing the water absorption, the hydration of the flour, the mixing speed, and the airflow that allow us to blow a bubble. Well, we are able now to analyze whole wheat flour. And here you can see the validation results of this protocol on 30 different flours. Again, we can see a lot of variability. So we have those methods. Let's try and see what they represent. So here, this is a quick study that we have done on 5 flours from different countries with different protein content, with different granulometries. And those 5 flours, they have been analyzed with the Mixolab and with the Alveolab. Here you can see the different bubbles, and you can see that, yeah, the granulometry already is not the same. They also have been analyzed through bread making tests, French baguette type. So here again, you can see the results, and you can see different bread shapes with different characteristics. If we try now to relate the results of the analytical methods with the bread making test, this is what we can obtain. First, if we focus on the mixing step, well, here with the Mixolab, we are able to have a very good prediction of the water absorption that we should use in the process. We have a very high correlation. And thanks to the same equipment, we are able to also have a good indication of what will happen during the mixing part. So here, if we focus on the first part of the curve, which represents the mixing really of the dough, we have an indication of the weakening of the dough, which is the C1 minus CS parameter. And this weakening is directly linked, negatively correlated with the mixing score. So if you have a higher weakening, you will have a lower mixing score, indicating that for making whole wheat flour baguettes, well, you need a high stability. Then we can focus on another important step of the process, which is shaping. This is really a key step as it will define the shape of the final product. And here, one critical parameter is the dough elasticity. So it's the capacity of the dough to be stretched and then to come back to its original position. If the dough is not elastic enough, the baguette will, well, risk to be too long. And on the contrary, if the dough is too elastic, then the baguette might be too short. With the Alveograph, we have a parameter that is called the elasticity index that is measured on the curve. And if we try to relate this index with the dough elasticity at the shaping step of the baguette making process, we can see that only one flour had a good elasticity. And this flour had a significantly higher elasticity. So here we are able to set up specifications. We know that we need a flour that will have at least this elasticity for making a good baguette. And of course, well, we are able to make sure that the final parameters are in control. For instance, we are able to predict the bread the bread volume thanks to the W value of the Alveograph. We have also been able to draw significant correlations with the Mixolab results. And again, we are able to set up specifications to obtain a compliant final product. Here on the Mixolab curve, we can focus on the gelatinization. And I don't know if you remember, but gelatinization is linked to the crumb structure. And here, if we focus on the height, on the intensity of the gelatinization, well, we can see that if we have a lower gelatinization, that we will have a better crumb score. So if I try to conclude about all of that, I might say that the need to evolve comes from the challenges that the industry meets. For the longest time, we have tried to use the same methods that were developed for white flour for other products, and including whole wheat flour. And the truth is, it doesn't work. It doesn't work because whole wheat flour shows specific constraints. So those methods are just not adapted. We have been able to develop new methods fully adapted to analyze whole wheat flour, and that shows correlation to the process. But it is only by starting over and by putting everything back on the table that we were able to do so. So I've shown you results about two equipments, but we have done the same kind of work with different equipment, with different methods, such as the S-Tematic or the SRC Chopin, or even the Rio F4, which is an instrument that is able to control the proofing characteristics of the dough, which is a step that I did not mention, but can be now controlled with the Rio F4. So of course, we are still at the beginning of researches. We definitely need to confirm this study with additional samples. We would love to try and make links with other types of processes to make pan bread, for instance, or biscuits. And well, we have done feasibility studies on various whole wheat cereals, such as rye or oats whole wheat flour. And literature is very rich in pertinent studies, especially concerning the Mixolab. But still, we have a lot of work to do. So if you are interested to know more, do not hesitate to contact us. Maybe we do have the answer. And if you are not, and if you do not, sorry, have the answer, we are always looking for industrial partnerships. So I would like to really thank you for your attention. And again, don't hesitate to contact us.